Previous videos have shown you what you will do in modules M1E and M2 during session 1. This video will show you module M3. It introduces some new ideas and has some work for you to do to solidify your understanding of those ideas. First, I'll open module M3. There is no E after the 3, so I expect that there will be one or more to-dos in M3. I see that the beginning part has lots of examples, but not much explanation. This video will provide the explanation for M3, and you can and should ask for clarifications and/or further explanation during session 1. You should run M3 as the first thing you do with it, so that you can see what it does. Hey, cool! I see that the program does some fun graphics. When movement seems to stop, just click anywhere in the window to close the window. The graphics here is called Turtle Graphics and has a long and distinguished history. If you are curious about that history, here are a couple of links you might enjoy. The first gives the early history of Turtle Graphics, while the second gives the history of the hugely influential programming language called Logo that incorporated Turtle Graphics. Let's look at the code in M3. Don't expect to master all that I say in the rest of this video. This video is just to help you get ready for doing M3 during session 1, where the deep learning happens. That said, line 1 imports the Rose Graphics module, calling it RG for short. That just means that there is a module, that is, file, called Rose Graphics at some special place in your setup, or, as here, inside your project itself. Importing it allows the program to access all the things defined inside that Rose Graphics module, simply by typing the abbreviation RG followed by a dot, like this. What I just did is called the dot trick. As it happens, you don't need to know anything today about what's inside the Rose Graphics module beyond the examples below, but that dot trick will frequently be useful. In line 8, the notation rg.turtleWindow, parentheses, says to go to the Rose Graphics module, locate the code that says what a turtle window is, and construct a turtle window object. The left-hand side of line 8 says that the name window refers to that turtle window object. So a name followed by an equal sign followed by a value makes that name be a reference to that value. In line 9, that turtle window object, which is now called window, calls its delay function, sending that function the number 50. To call a function means to go to the function's definition, run its code, then come back to where you were. We will talk about that lots more in subsequent videos. When the function name follows an object and a dot, we call the function a method. Again, lots more on that later. That particular method, the one called delay, makes the animation a bit slower than its default, so that you can see the turtle motions a little easier in this example. Line 14 is very much like line 8. Do you see how they have the same form? Line 14 constructs a SimpleTurtle object as defined in the Rose Graphics module. It makes the name Nadia refer to that object. Line 15 constructs a second SimpleTurtle object and makes the name Akil refer to that second SimpleTurtle. When you next run this program, notice how Nadia, the SimpleTurtle that will move first, looks different from Akil. That is because of the information, quote, turtle, quote, that is sent to the SimpleTurtle construction method for Akil. We call characters inside quotes like that strings. Lines 20 to 29 are all very much like line 9, except that these lines do things that SimpleTurtles can do, while line 9 did something that only a turtle window can do. All these lines follow the who, dot, does what, with what pattern. For example, line 20 asks the SimpleTurtle named Nadia, that's the who, to move forward, that's the does what, a distance of 100 units, that's the with what. In session 1, you should run the program again at this point to see what the forward method and other methods seem to do. Let's do so. There is Nadia, moving forward 100, then turning left 90 degrees, then moving forward again 200 units. Now Akil turns right 45 degrees, goes backward 50 units, then turns right 60 degrees. Then Nadia moves forward 50 and left 135 degrees. We'll come back to the rest of the run shortly. Of course, Just ask in class if any of these methods are not clear to you. You can also learn about the code by using the dot trick, like this. In the information that pops up, all of the names with an M beside them are methods that a SimpleTurtle, like Nadia and Akil, can do. If you click on one of them, like this, it pops up some documentation that explains what that method does. We do not want you to start memorizing a bunch of SimpleTurtle methods, nor do we expect that the documentation will make total sense to you. Just use these examples to start getting used to the who does what with what pattern in a fun way. Okay, one last idea in M3. Look at lines 36 to 40. Those set characteristics of the two SimpleTurtles, Nadia and Akil. We call such characteristics attributes, or, more commonly, instance variables. For example, line 36 sets Nadia's pen instance variable to a newly constructed pen object whose color is blue and whose thickness is 10. After that line, Nadia's SimpleTurtle uses its new blue thick pen to draw its lines. Likewise, line 37 sets Nadia's speed instance variable to 10, which makes Nadia move much faster thereafter. Do you see why Akil starts using a very thick red pen after line 39? Note the absence of parentheses on the left-hand sides in lines 36 to 40. That is why pen and speed are instance variables, while forward and left, which do have parentheses, are methods. By the way, the file colors.txt in your project lists all the strings that you can use as names for colors. Again, don't expect all of this to sink in yet. We will do lots of practice with these ideas. In doing that practice, in class where you can ask questions easily, that's where you will master this material over the next week or so. Finally, note that M3 has a to-do. Item 1 asks you to re-examine what we just discussed. Item 2 asks you to put some lines that make Nadia or Akil move around. For example, you could add this. Let's run to see it work. Uh-oh, looks like I goofed. If you see red in the console, or if the window closes prematurely, then something went wrong. In this exercise, it will usually be a spelling error. This time, after I retype the dot and a few more letters, I will press the Enter key to let Eclipse type the name for me. You should try that too. If you get any error messages during session 1, don't hesitate to ask for help fixing them. You will not master error messages right away. That will take several sessions. Last thing, the third to-do asks me to construct another SimpleTurtle, then make my SimpleTurtle do something. For example, I might type, the lines that I typed actually construct two objects, a SimpleTurtle, which gets called Sarah, and a pen that is set to be Sarah's pen. Again, if anything goes wrong when you do this in session 1, first look for a spelling typo, and then be quick to ask for help as needed. To summarize, there are 3 key ideas in M3. First, lines like this show you how to construct a SimpleTurtle as defined in the RG, short for Rose Graphics, module, and how to give that turtle a name, here Nadia. Second, lines like this show you how to ask an object, here Nadia, to call, that is run, a method, here forward, possibly sending that method some information, here 100. That is the who does what with what pattern. Third, lines like this show you how to ask an object, here Nadia, to change the value of one of its instance variables, here speed, to a new value, here the number 10. This video has shown you how you will do module M3 of session 1. There will be lots of people to help you with the modules during session 1. So don't worry if you're fuzzy on anything at this point. Just have fun with the turtles.